Hi, my name is Melissa Hatchie, and I am pleased to welcome you to today's presentation on climate change, with a specific focus on its impact on our local community in southern Mississippi. Today we'll talk about climate change, examine its causes, and discuss both the current and projected effects on our environment and society. Our goal is to understand these changes and identify effective strategies for mitigation and adaptation to safeguard our community's future. I look forward to engaging with you all on this topic and sharing valuable insights that can help guide our collective actions. Climate change refers to substantial changes in weather patterns and temperature over time. It's driven by the increase in greenhouse gases like carbon dioxide and methane in the atmosphere, mostly due to human activities such as burning fossil fuels, deforestation, and industrial processes. Climate is essentially the long-term pattern of weather in a particular area. It's shaped by factors like temperature, humidity, precipitation, and wind over extended periods. Changes in climate are driven by variation in Earth's energy balance, which is the equilibrium between the energy the Earth receives from the sun and the energy it emits back into space. In southern Mississippi, climate change can be seen in rising temperatures, changes in rainfall patterns, and an increase of extreme weather events like hurricanes and floods. These changes can lead to severe environmental and social impacts. As global temperatures rise, southern Mississippi is likely to experience more intense and frequent rainfall events, leading to flooding that can damage homes, infrastructure, and agriculture. Warmer sea surface temperatures in the Gulf of Mexico can enhance the intensity of hurricanes, posing greater risks to life and property in coastal and inland communities. Changes in climate patterns can affect the planting seasons, crop yields, and the types of crops that can be grown, impacting local food security and agricultural economy. Two specific activities that have influenced climate change in this area are energy production from fossil fuels and agriculture. Fossil fuels are used for transportation and energy in homes and businesses and can contribute to greenhouse gas emissions. Even in smaller communities, cars, trucks, and agricultural equipment release carbon dioxide and other gases that trap heat in the atmosphere, leading to a warming effect known as a forcing factor. Southern Mississippi is in a region with a lot of agricultural activity. The use of fertilizers in farming releases nitrous oxide, a potent greenhouse gas. There are a lot of livestock farms where methane produced by animals also contributes to warming. These are examples of forcing factors because they directly add greenhouse gases to the atmosphere, which traps more heat. Agriculture can also impact land use. When natural vegetation is cleared for farming, it reduces the area's capacity to absorb carbon dioxide, creating a feedback loop. Fewer trees means less carbon dioxide is taken out of the atmosphere through photosynthesis, which can lead to increased local and regional temperatures. While these contributions from a small community might be minor on a global scale, when they are multiplied by similar activities in thousands of communities worldwide, their cumulative effect becomes a major driver of global climate change. Addressing climate change in southern Mississippi involves mitigating the root causes. This can be done by reducing greenhouse gas emissions and adapting to its inevitable impacts to protect communities and assure the sustainability of local economies and ecosystems. I would like to go into a little bit more detail regarding climate change. Climate change refers to a long-term change in climate patterns. Over decades to millions of years, these changes can occur due to various factors like geographic transformations and solar radiation levels. Most recently, climate change is being driven at an unprecedented rate due to human activities that increase the concentration of greenhouse gases in the atmosphere. Burning fossil fuels is the main source of increased atmospheric carbon dioxide. Cars, power plants, and industrial processes that burn coal, oil, and natural gas contribute significantly to this problem. Removing forests decreases the amount of carbon dioxide captured through photosynthesis and increases the amount of carbon dioxide released into the atmosphere. Many industrial processes emit a variety of greenhouse gases like methane and nitrous oxide, which are more effective than carbon dioxide in trapping heat in the atmosphere. Mississippi's climate, influenced by the air from the Gulf of Mexico and the continent, has warmed slightly since the early 20th century, with a net increase of about 0.1 degrees Fahrenheit. The state experienced warmer temperatures in the early to mid-20th century, followed by cooling in the 60s and 70s, and a return to warmer conditions with a rise of over 2 degrees Fahrenheit since then. Recent trends include fewer extremely hot days since 1955, more warm nights, and more extreme precipitation events. The state's vulnerability to extreme weather is highlighted by devastating hurricanes like Camille in 1969 and Katrina in 2005. The trendline equation for Canton, Mississippi during the winter months on the left indicates a warming trend of 0.0102 degrees Celsius per year, suggesting a gradual increase in temperature over time. However, the low R-squared value of 0.0468 suggests that this trendline only explains about 4.68% of the temperature variability, indicating significant influence from other factors such as human activities, including emissions, deforestation, and urbanization. For annual temperatures, the trendline shows a warming of 0.0118 degrees Celsius per year, with an R-squared value of 0.3271. This means about 32.71% of the temperature variation is explained by the trend over time, leaving over 67% influenced by other unaccounted factors in the simple linear model. These graphs depict summer and annual precipitation patterns in Mississippi over the last century in 5-year increments. Summer precipitation has fluctuated significantly, ranging from about 10 to 25 inches, without showing a clear upward or downward trend. However, recent data suggests a slight increase in both median and range of precipitation, indicating potentially wetter and more variable summers ahead. Future planning should therefore prepare for the wide range of conditions, including both unusually dry and wet summers. The annual data also shows considerable variability, with precipitation ranging from 40 to nearly 80 inches and occasional extreme weather events. While there is no clear long-term trend in median annual precipitation, recent periods show a slight increase. This suggests ongoing variability and the possibility of extreme events such as heavy rainfall and floods in future years. These predictions do not account for the potential impacts of climate change, which could alter these patterns and increase the frequency and intensity of extreme events. Future climate predictions for Mississippi indicate a significant warming trend, with potential temperature increases of up to 13.5 degrees Fahrenheit by the end of this century, depending on greenhouse gas emissions. This warming could result in fewer days of freezing temperatures and might reduce summer rainfall, posing challenges for agriculture and water management. Additionally, the risk of hurricanes and storm surges is expected to rise due to increasing sea levels, which could lead to more frequent and severe flooding along the coast. These changes are likely to have major effects on Mississippi's agriculture, infrastructure, and coastal areas. Using the trendline equations from our graphs, we can project future climate changes. The average winter temperature increase is 0.0102 degrees Celsius per year, translating to 0.102 degrees per decade and 1.02 degrees per century. Similarly, the overall annual temperature increase is 0.0118 degrees Celsius per year, which amounts to 0.118 degrees per decade and 1.18 degrees per century. By these projections, by 2034, the average temperature could rise by 0.118 degrees, and by 2124, it could increase by 1.18 degrees. These predictions assume a constant rate of change. However, realistically, increased emissions or effective climate mitigation could alter these rates significantly. A USDA study found that rising greenhouse gas concentrations, along with changes in temperature and CO2 levels, impacted both irrigated and rain-fed cotton yields. While increased CO2 may enhance photosynthesis and initially boost cotton yields, rising temperatures reduce the growing period and crop water efficiency. In the short term, irrigated cotton may see slight yield increases due to the CO2 fertilization effect. However, long-term projections indicate significant yield reductions by 2080, particularly under high-emission scenarios, as temperatures exceed optimal growth thresholds and shorten the growing season. Rain-fed cotton, on the other hand, faces yield decreases under all scenarios due to higher temperatures and insufficient rainfall. Although increased CO2 levels can partially mitigate these effects, water scarcity remains a critical issue. The study suggests that adapting planting dates and providing supplemental irrigation could help counteract climate impacts. Cotton is a vital crop in Mississippi, and it could see yield reductions of up to 15% by 2050 due to the 2 to 3 degree Fahrenheit warming. Climate change is affecting precipitation patterns in southern Mississippi as well, potentially decreasing surface water levels by up to 20 degrees in parts of the Mississippi River Basin over the next 30 years. This could impact irrigation practices and agricultural productivity. The Mississippi River, running from Minnesota to the Gulf of Mexico, has seen ecological changes, including warmer winters, increased temperatures, and more extreme precipitation events, and earlier ice-off timings. A study attributes increased soil erosion in the Mississippi River Basin primarily to climate change. While land use changes historically drove sediment levels, intense rainfall from 1980 to 2000, particularly in southern forested areas, has intensified soil erosion in croplands. This erosion not only threatens water quality and raises drinking water treatment costs, but also compromises agricultural productivity by stripping away topsoil. The economic ramifications are substantial. This map was pulled from the Division of Agriculture. I've highlighted the cotton category on the right-hand side. Cotton is responsible for almost $485 million of the state's GDP. Losing even 10% of the crop yield would mean losing $485,000 annually. With the predicted decrease in rainwater availability, existing irrigation infrastructure may become inadequate, requiring upgrades or replacements. This could necessitate additional funds to maintain crop yields and prevent soil degradation. Southern Mississippi has the potential to enhance its renewable energy commitment, particularly in solar power, due to its geographic location. Initiatives could include incentives for installing solar panels in various sectors and establishing community solar projects to benefit those unable to install panels directly. Additionally, the state's extensive forested areas need effective management and reforestation to sequester carbon, boost biodiversity, and combat soil erosion. Programs could focus on planting native species, pest management, and wildfire prevention. Southern Mississippi must adopt strategies to address the heightened risks of extreme weather. This includes improving flood management through the construction of levees, enhanced draining systems, and green infrastructure like rain gardens and permeable pavements to manage stormwater runoff. Community planning should also revise zoning laws to limit development in flood-prone areas. In agriculture, adapting to changing climatic conditions is crucial for maintaining crop yields. Strategies might include developing drought-resistant crops, employing more efficient irrigation methods, and adjusting planting schedules to suit new temperature and precipitation trends. Additionally, education and support programs on climate-smart agriculture techniques will be essential for assisting farmers with these transitions. In our presentation, we examine the effects of climate change on southern Mississippi, focusing on the historical and projected increases in temperature, altered rainfall patterns, and more frequent extreme weather events. We discussed how local activities amplify these changes, posing threats to our agriculture and infrastructure. We propose mitigation strategies to reduce our carbon footprint, like adopting renewable energy, improving energy efficiency, and practicing sustainable agriculture. We also highlighted adaptation strategies, including better flood management and adjusted agriculture practices to enhance community resilience. Moving forward, it's critical for our community to unite and implement these strategies to ensure southern Mississippi's resilience against the changing climate. For more information, please visit any of these references.